That last video seemed like it was getting very long, so I thought we should split this into 2 different videos. Okay, so last example, we were given a rule and we're finding the new shape. This time, what if I tell you I've got my pre-image, STUV, and I have my image, S prime, T prime, U prime, V prime, and I want you to tell me what the rule would be. So I'm going to say I want to figure out, I basically just have to figure out how far over it is from S to S prime, because we know that they all have to be the same. So for this, to go from S to S prime, I had to go down 1, 2, 3, 4, and then I had to go back to the left 1. So my rule that I would write is the transformation would be, let's see, X is always written first, so -1 down -4 and that's of STUV equals S prime, T prime, U prime, V prime. Okay, so what that is saying is it's saying transform STUV by moving left 1 and down 4, and that will equal your new points for STUV. So why don't you guys go ahead and try it? This one is just a point. So I want you to figure out what the rule is that maps P to P prime. So take a second and do that, and then I'll see you in a sec. Okay, so if I'm going to go from P to P prime is at 2, 3, I have to think about how I'm moving. So from -3 up to 2, I have to move 5. So my transformation is going to start by moving to the right 5. And then if I compare from 1 to 3, I have to go up 2. So that would be 2. And that is what if you transform P by going over 5 and up 2, that will equal P prime. So there's your answer. Okay, guys, we could also do more than one transformation at a time. And we call this a composition of rigid motions. So, oh goodness, it's raining. You can probably hear that in the video. But a composition of rigid motions is a transformation with 2 or more rigid motions in which the second rigid motion is performed on the image of the first rigid motion. So let's say I'm going to translate this triangle. Oh, that was terrible. Here's a triangle. I'm going to move it so that I go left 2 and up 5. So back 2, up 5. And my new triangle is going to be here. So if this was A, B, C, this is A prime, B prime, C prime. And then I'm going to reflect that across a line. I'm going to say this line is right here. Here's L. If I reflect that across the line, that means it's going to come down here. And I'm going to have B double prime, A double prime, C double prime. Notice that I'm putting 2 primes to show that this is the transformation of this image. So this composition takes A, B, C, maps it there, and then maps it there. That's what I'm talking about when I say a composition of rigid motions. So let's look at an example. So here we have Kyle, who is learning how to dance. And he's going to start here, and then he's going to move his feet there, and then he's going to move his feet there. So we're going to look at about how this is moving. I'm going to put a point right there, just so I have, kind of like in our lizard example, it will be easier for me to see exactly how that point is moving, and then the rest of the picture will follow it. So Carl's moves from position A to position B, and then to position C. So from A to B, I'm going up 2, over 1, 2. So my going from A, I'm going to go to the left, to the right 2, and I'm going to go up 2. And that is going to equal A prime. Then I'm going to take A prime and I'm going to move. So this is where my point ended up, right there. I'm going to take that and move it to point C. So I'm going down 1 and over 1. So to map A prime, I'm going to the right one. So that's positive 1, and then I'm going down 1, which is negative 1. And that equals A double prime. Okay, but this question, so I did two things. I moved up to B, and then I moved back down to C. It's asking what single transformation describes Kyle's move from position A to position C. Well, I could rewrite that as, think about it. In total, we moved horizontally 3, and in total, 2 minus 1 would be we moved only up 1. So I could rewrite this as A goes over 3, up 1 to A prime, which is the same as where C is. Okay, so and we could double check that by just saying, well, this would be the translation would go over and up. So I would go 1, 2, 3 to the right and up 1, and that's what we got. Okay, so now you're going to try this composition of functions. Okay, so for notation, this little circle shows composition of. Okay, and it says you're going to do this transformation, and then you're going to do this transformation. So how could you guys write this? So imagine you're first going to move your feet or a step or some lizard, something. You're going to move it to the right 3 and down 2, and then you're going to move it to the right 1 and down another 1. So go ahead and answer the question, and then I'll tell you what the answer is. All right, so your answer would be, if I'm going to move 3 to the right and then another 1 to the right, my new transformation will be 4 to the right. And then if I'm moving down 2 and down another 1, I will have moved down 3 altogether. So that would be my transformation written as one translation. All right, so our next concept is that we can actually, so this is another composition of functions. So if I do 2 reflections, it turns out that that is actually the same as a translation. And I want you to imagine this. So we've got this triangle right here, ABC. We're going to flip it or reflect it over the y-axis. So when I do that, I'm going to get all the way over to here. So remember from last class, when we reflect something over, oh, that's a highlighter. When we reflect something over an axis, so if this is our line of reflection right here, all of the points, when I connect, these have to be the same distance, right? So C to C prime, the distance from C to the line of reflection is the same as from the line of reflection to C prime. And same with A to A prime, and then B to B prime. So this distance and that distance are the same. So can you see that we have taken, imagine you're folding a paper over this line, that triangle ends up over here. Okay, so that's our first reflection. And our notation for a reflection is we're going to write a capital R, and then we're going to write the name of the line. So this other line is M, so I'm going to call this one L. So a reflection around L, that's what it's going to look like. And you could also have written like reflection over the y-axis, something like that, if you didn't have a name for it. But the capital R with a little letter next to it means reflect over line L. And this one means reflect over the y-axis. So you get the point. Okay, so now what I'm going to do is I'm going to take my image. So remember, this is the pre-image. Here's the image when it's been reflected over the y-axis. And I'm going to reflect it again over this line. So when I do that, I'm going to have C to C prime, A to A prime, B to B prime. They're still perpendicular. All these pieces are still same lengths, but I end up with this little figure right here. And notice what it looks like. I mean, we're back to the original orientation. So when I reflected, I flipped it, and when I reflected again, I flipped it back. So what we see is that when you reflect twice, it's actually the same thing as just sliding it. So a composition of two reflections is the same as a translation. The interesting thing that happens though here, I'm going to erase some of my lines so you can see better. Okay, notice, let's count and see how far is it from A to A prime. It's 1, 2, 3, 4, 6, 7, 8. So that distance from A to A prime is 8. How far is it between the two lines that we reflected it over? 1, 2, 3, 4. And it turns out that we always have this relationship that this distance right here, the distance between the two lines of reflection, it's always going to be the translation will be twice whatever the distance is between these. So this translation where we're sliding the pre-image to A double prime will be twice as long as whatever the distance is between those two lines of reflection. Let me show you how you're going to use that information. So for example, I've told you here that you have a line n at x equals -1 and a line m at x equals 3. So I'll draw pictures so you guys can see what that means. So I've got, remember when it says just x equals something, that's a vertical line. So I have a vertical line at -1. And I have a vertical line at 1, 2, 3. Should do this one a different color. Do this one red so you can tell which ones are the axes and which ones are the lines. Okay, so this is N and this is M. So I want to see how far is it between those two lines. Well, it's 1, 2, 3, 4. So this distance is 4. So that means if I were to take any point or object or anything and reflect it, so if I have some point here and I'm going to reflect it twice so that it ends up like this is A, here would be A prime, and I'm going to reflect it back one more, so this goes to here. I'm going to reflect it back one more time, and this will be A double prime. Okay, the total shift, the translation from A to A prime, to A double prime, will be twice as big as that. So our x direction will be 8, and our y direction, since this is going over vertical lines, will be 0. Okay? Remember, you're going to find the distance between your two parallel lines, or your two lines of reflection, and then you will double whatever that distance is, and that is your translation. So why don't you guys go ahead and try it. if you have a line at n, which is at x equals -4, and another line m at x equals 6, what is the composition of reflections? Write the composition of reflections as a translation. So, okay, so go ahead and try it. All right, guys, so if I've got a line at n equals -4, and I've got a line at 1, 2, 3, 4, 5, 6. Here's my 2 lines of reflection. The distance between there is a total of 10. So my translation will have to be twice as big, which will be 20. And since these are vertical lines, we're just shifting like here to here to here. So you won't have any vertical change. Okay, hopefully you got that right. Okay, so this is just to sum up. Translation is a transformation that maps all points the same distance and the same direction. Okay, you're really just sliding it along a line from one place to another. The line segments that connect the pre-image and the image will all be parallel to each other. And you know that the distances from the pre-image to the image, all of those segment lengths, notice these. This one, and this one, and this one. Those will have to be the same length because you have to move up and over the same amount. Okay, the other thing was we can write a translation as the composition of 2 reflections. So we can flip it once and then flip it twice, and that will be the same as just having slid it over. Okay, and then remember that the distance from A to A prime, B to B prime, and C to C prime will all be the same, and it will all be twice the distance between the 2 lines of reflection. All right, so all you have left to do now is in Google Classroom, there's an assignment. I included the textbook pages so you can see them, but you can just write your answers on a separate piece of paper. You're going to be doing page 119, 15 through 33, 3K. That means every third problem. So you do 15, 18, 21, 24, 27. I do not want anybody to have homework over fall break. We all just need a break. So if you do not get this finished, you are welcome to finish it now, this weekend, tomorrow, whatever. But I'm not going to check it, and I'm not going to do a mastery check until the 18th for A day and the 19th for B day. So you'll have time, but if you don't do it, you'll just have to remember you'll do 2 assignments when we get back. But totally up to you, no pressure. Have a good break. I hope you all enjoy yourself and rest up and get ready to get back and have a great rest of the semester.